Good day, grade 9s. How are you guys doing today? Today we're going to be looking at the reactions of nonmetals. Reactions of nonmetals. If you recall, in our previous lesson, we talked about nonmetals in general. We talked about nonmetals in general, where we looked at the properties of the nonmetals. But first, obviously, we looked at some examples of the nonmetals, where they are located on the periodic table, and we said they are located to the far right of the periodic table. Yes, we looked at the properties of the nonmetals in comparison to the properties of the metals. And what we're going to do today is we're going to continue with this concept of nonmetals. Today, looking at the following objectives. By the end of this lesson, we should be able to describe the reactions between nonmetals and oxygen, describe the reactions between nonmetal oxides, right? Because when nonmetals react with oxygen, they form nonmetal oxides. So we should also be able to describe the reactions of nonmetal oxides with water. We should also then, by the end of this lesson, then explain how acid rain is formed and the effects of acid rain. The effects of acid rain. So just look at those objectives. Make sure that you are in the right frame of mind for the lesson. Pause the video for 15-20 seconds and just compose yourself. Okay, so we said we're looking at elements that we refer to as being non-metallic elements. And we gave examples of those elements as being carbon, phosphorus, oxygen, sulfur. Those are examples of non-metallic elements. And when they react with oxygen, what is the product that is formed? So we'll find here that when carbon reacts in air, the example that is given there that I gave there first was if carbon reacts with oxygen, it will produce either carbon monoxide or it will produce carbon dioxide. And I indicated there that if carbon reacts with a limited amount of oxygen, it's going to produce carbon monoxide. But if it's going to react in a situation where there is an excess of oxygen, the carbon will react with an excess of oxygen and it will produce carbon dioxide. Okay? So the important thing to note here now, what we are mostly concerned with, is the knowledge that when nonmetals react with oxygen, okay, so you're thinking of a nonmetal. Think of a nonmetal, carbon, sulfur, phosphorus, yes? Think of one of those nonmetals, the equations, you can see the equations are there. When these nonmetals react with oxygen, they form acidic oxides. That's a key part. If you're going to walk away from this lesson with something, please know that nonmetals form acidic oxides. Right? I even said NB on the notes. NB, point note, important point. Nonmetals form oxides which are acidic in nature. And if we were to have a comparison with the metals, you will find that metals, can you please try and think of a metal? Try and think of a metal. Think of any. We have so many metals on the periodic table. Those metals, let's say magnesium, let's say calcium, if they react with oxygen, the oxide that they produce, what do you think is going to be? Is it also going to be acidic? If nonmetals are producing acidic oxides, it means metals are going to be producing the opposite of that, which is basic oxides. Basic. Okay? So what I want you to do is, at this moment, right, of your own volition, pause the video, go back and just quickly look at the notes on acids and bases, right? try to look at how you differentiate acids from bases, indicators, all of that material. Just pause the video for a minute and do that quickly. Okay, so now what we're going to do is we're going to watch a short video showing us the reaction of metals and nonmetals with oxygen, right? It's very graphic, and I think it will help you to remember the concepts more, okay? So I'll just pause it here and there to explain some of the material that I think would be very relevant. All of it is relevant, but some things are more relevant than others.
Metals and nonmetals. Most of the elements in the periodic table are metals, and they generally have 1, 2, or 3 electrons in their outermost shells. Nonmetals, present to the right side of the periodic table, have 5, 6, or 7 valence electrons.
Okay, so quickly, you see where it says valence electrons, valency electrons. Valency electrons are the outermost shell electrons, right? So if you're asked to say, take for example here for chlorine, sulfur, phosphorus, sulfur, chlorine. So if you're asked to say, how many electrons does sulfur have in its outermost shell? You will say it is 6 electrons. The same question can come and say, how many valency electrons does sulfur have? How many valence electrons does sulfur have? And you again say 6 electrons, because valence electrons are outermost shell electrons.
As the number of valence electrons decides the chemical properties of an element, metals and nonmetals differ in their chemical properties. In this topic, we will learn how to distinguish between a metal and a nonmetal based on their reaction with oxygen. Take a magnesium ribbon and burn it in air. It burns with the bright white light to produce magnesium oxide. Here, magnesium reacts with oxygen and forms magnesium oxide, which appears as a white residue. Collect this residue. Dissolve it in a small amount of water. The magnesium oxide dissolves in water, resulting in the formation of magnesium hydroxide.
Okay, so at this point, I'm sure the visuals are okay. The visuals are good. The images that you're seeing, right? But what I also want you to look at is the equation, right? In the previous, in the last exercise that only a few of you wrote, I remember, I know that Ellen submitted, Philemon submitted, Fortune submitted. It's just 6 people who submitted. The rest of you, I don't know what you were busy doing. So for those who submitted, I ended up commenting on the states of matter to say when you write an equation, a chemical equation with the symbols. If you say magnesium oxide, you must know which state that magnesium oxide is in. Water is probably the simplest one, because water, you just know, okay, water is in the liquid state. Magnesium hydroxide is what? Is in aqueous state, right? Then also that the equation should always be balanced. Those are the things that I need you guys to always keep in your mind when you are writing chemical equations. Your equations should have the correct state symbols, and your equations should always be balanced. Always try and balance your equation. Even when it seems like it's difficult, try and always balance your equation. If you don't know how to balance your equation, I would advise you to say, when we're in the lesson, ask me, and then we'll give you several examples, and I will balance the equations together.
Dip a red as well as a blue litmus paper into this solution. The red litmus paper turns blue, indicating that the solution is basic, while no change is observed in the blue litmus paper. This activity confirms that a metal forms a basic oxide on reacting with oxygen. Now, take some sulfur, which is a nonmetal, on a deflagrating spoon and start heating it on a burner. It first melts and then starts burning to form sulfur dioxide.
Observe the equation. Observe the equation for the formation of sulfur dioxide. Please observe the equation at the top there.
Immediately, dip the spoon in a beaker filled with water and cover the beaker with a lid so that the gas does not escape. This trapped gas now dissolves in water, resulting in the formation of sulfurous acid. This is verified by immersing red and blue litmus papers into this solution. The blue litmus turns red, while the red litmus remains unaffected.
Okay, so the other important thing is that we must also be familiar with our indicators, right? If you're just seeing how red litmus paper is unaffected and you don't know the implications of that, this whole video is meaningless to you. What you must be in a position of is knowledge to say, okay, so if I'm given blue litmus paper and it remains blue, what does this mean? If I'm given blue litmus paper, I dip it in a substance and it turns red, what does this mean? That information is vital to you, which is why I said earlier, go back to the lesson on acids and bases. Look at the indicators. Okay? Look at the indicators.
Thus, nonmetals react with oxygen to form their respective acidic oxides.
Okay. So we now know that, so if you have nonmetals reacting with oxygen, they react with oxygen to form their respective acidic oxides. Acidic oxides, right? Acidic oxides. Whereas with metals, they will form their respective basic oxides. Respective simply means that if you have copper, iron, calcium, and they react with oxygen, then they're going to form iron oxide, copper oxide, if it's copper 2 oxide or copper 1 oxide or calcium oxide, right? So that's how nonmetals react with oxygen to form acidic oxides. And then we also wanted to talk about how then those acidic oxides can then react with water. Okay? So now you have produced an acidic oxide, sulfur dioxide, and it then reacts with water. When sulfur dioxide then reacts with water, as you saw, it then forms for you sulfurous acid, right? And if we were to add another oxygen to make it H2SO4, because sulfurous acid, if you observed on the diagram, it had a double bonded oxygen. You break that double bond, join another oxygen, gives you sulfuric acid, right? So when you then react the nonmetal oxide with water, nonmetal oxide reacting with water is what gives you an acid. So you guys, like I said, all these spaces, you will write the respective symbol equations, balanced equations. I had to do this one for you, the one for phosphorus pentoxide, because it's just a little bit too complicated for nothing. So I did it for you guys to avoid headaches. So you will fill in, write the correct symbol equations, and that will be your exercise. Which you will submit on Friday the 5th. Yes, Friday the 5th. You submitted that. So now we also wanted to talk about how you have the formation of acid rain. What happens is, if you think of pollution, right? Before I go there, right? You have this document. That's the good thing. You have a PDF document of this one. And I said, you'll fill in. I wanted to pause the video for you guys, or for you guys to pause the video, but I realized that you have the PDF, so you can just fill in, right, and you write the answers for me. In terms of acid rain, so we're saying the non-metal oxides. You have carbon dioxide. We know a good source of carbon dioxide. We are a good source of carbon dioxide. When we breathe that carbon dioxide, it goes into the air, right? It goes into the air. When we burn plastics, when we burn tires, they produce sulfur dioxides, right? These are harmful oxides, if we think of them, nitrogen oxides. So when this sulfur dioxide goes into, it's now there in the air. It's now in the atmosphere, right? And remember, we've just came out of a very heavy rainy season. So when all that rain was coming down, when the rain was coming down, the rain, which is H2O, water, is coming down, and as it is there, is coming down, it reacts with the sulfur dioxide, which is in the air. Okay? So you have this chemical process taking place during cloud formation. You have this water that's there in the clouds. You have this sulfur dioxide that's also there in the atmosphere. And they are reacting, and they produce acids. If it's sulfur dioxide reacting with the water, forms sulfuric acid. If it's nitrogen oxides, they form nitric acid. And this is then the rain that comes down. And you're thinking the water is clean, but effectively it's actually now a weak acid. It's now a weak acid. So these then would be some of the effects of that acid rain on the environment. It says damages the wax coating of plant leaves. You can read through. You can read through the effects of the acid rain on the environment. You can read these effects. So you will find that acid rain has harmful effects to the environment, whether it's the natural environment or the man-made environment in relation to, or in terms of our infrastructure. If you look at your buildings, if you have good buildings, nice buildings that have nice paint, painted nicely, when there is all this acid rain, it's going to wash off that paint. Not all of it completely, but you will just see the stains, right? You will see you've painted your house looks nice, you've painted it with a bright yellow color, but before you know it, it just stains. It looks like it's dirty. Why? Because of the acid rain that has gone onto those walls, right? So that's why it says there, it corrodes buildings. Just imagine point number 2, it says it prevents chlorophyll formation. Try to think of all the harmful effects or all the negative effects that will be caused by a lack of chlorophyll formation. Because you know chlorophyll is important in the process of what? In the process of photosynthesis, right? So I just gave you a small question there. How does burning fossil fuels, blah, 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 cause all of those things, right? So we'll discuss all this material again in the lesson. Let's see if we manage to cover our objectives for today. So are we now able to describe the reactions between nonmetals and oxygen? I would say so. Then the reactions of the nonmetal oxides with water, definitely. Then how is acid rain formed? These 2 points are basically the same, right? These 2 points are basically the same. Explaining how acid rain is formed is the same as the reaction of nonmetal oxides with water. So, guys, this is effectively the end of the lesson. Thank you very much. If you were able to watch through the entire material and are still here at the end of this lesson, listening to this voice, thank you once more. Marshall A.C. Candiado, out.